Hi, welcome students. Here I am going to discuss about memory segmentation of 8086. Before that, why we need the memory segmentation? First, in order to implement Harvard architecture. Harvard architecture means there is a separated or there is a dedicated memory for data as well as there is a dedicated memory for program or instruction. In von Neumann architecture, there is no concept of separate memory for data as well as program. But in Harvard architecture, there is a separate memory for program as well as data. In order to implement Harvard architecture, 8086 support segmentation. Then next point is easy to debug. In order to easily debug, we are separating the memory for data as well as program. Some same interfacing ICs can be used in 8086 because before 8086 there are so many IC chips which were supporting 8085. Same interfacing ICs can be used in 8086 by implementing memory segmentation. Then, in order to avoid the overlap of stack with the normal memory, we can use memory segmentation in 8086. And in order to compatible with 8085, 8086 supports memory segmentation. Then, actually 8086 is an improvised version of 8085 architecture. Actually, the data associated with 8086 is 16-bit. The address bus is 20-bit. That is, this address is 20-bit in the case of 8086. So that in total 2 raised to 20 memory location it can be addressed. 2 raised to 20 means 1 MB memory can be accessed in the case of 8086. This memory is divided into 4 segments. First one, code segment, data segment. Second one is data segment. Third one is stack segment. And finally, extra segment. CS stands for code segment. DS stands for data segment. ES stands for extra segment. SS stands for stack segment. These CS, DS, ES, SS are actually segments associated with the 8086. There are 4 types of segment registers associated with these segments. These are CSR, DSR, ESR and SSR. These stack segment registers actually storing the starting address of the corresponding segments. Here there is an example. This is the 1 MB memory of 8086. These are divided into 16 segments. Each segment size is 64 KB. It can be extra segment, stack segment, code segment or data segment. Whatever, each segment size is 64 KB. And associated with each segment, there are corresponding segment registers. It is used to store the starting address of the corresponding segments. Here, this is the data segment. This is the size is 64 KB and the starting address of this data segment is labeled as 2000. This 2000 is stored in the corresponding data segment register, that is DS. This DS is storing what? The starting address of the corresponding data segment, that is 2000. Similarly, in the code segment is starting from the memory location 3000. That is, the starting address of the code segment is 3000. This 3000 is stored in the register CSR, that is code segment register. Similarly, the stack segment, the starting address of the stack segment is 5000 and it is stored in the corresponding stack segment register, that is SS. 5000 is stored in SS. Similarly, extra segment static address is 7000 and this 7000 is stored in extra segment register, that is ESR 7000. Okay, that is 1 MB memory is divided into 16 logical segments and each segment size is 64 KB. Here one more picture is given. These are the 4 segments and CS is the code segment register. It is used to store the starting address of the code segment. TS is used to store the starting address of data segment. SS is used to store the starting address of stack segment. Similarly, ESR is used to store the starting of the extra segment, and each segment has size of 64 KB. This full memory is 1 megabyte memory of 8086. Actually, in the case of 8086, the physical address is 20 bit, but this segment registers is used to the segment registers can store only 16 bit. So in order to calculate the 20-bit physical address, we have to add base address plus offset address. From where this base address can be get? It can be accessed from the corresponding segment register. What is this offset? Offset is actually the displacement from the starting location. By adding the base address plus offset, we get the 20-bit physical address. Here it is the calculation. This segment register that is actually holding 16-bit capacity. Okay, each segment register is storing the starting address of the corresponding segment, and this segment register's capacity is 16-bit. Okay, but the physical address is actually 20-bit. In order to convert this 16-bit into 20-bit address, we are appending 4 zeros to the right hand side of the segment register, so that we can convert the 16-bit into 20-bit. This address is added with the offset value, then we will get the final effective address, that is of 20-bit in the case of 8086. There are likewise, for completing the physical address, which is 20-bit long, is generated using segment register and offset register, which is of 16 bits long. For generating a physical address from the content of these two registers, the content of a segment register, also called segment address, which is shifted left bitwise 4 times, and to the result, the content of an offset register, also called as offset address, is added in order to produce this 20-bit physical address. Then there are 4 segments, as I told you: DS, CS, CSS and ES. 4 segment registers which will hold the upper 16-bit of the starting address of the segment. Then size of each segment is what? 64 KB. The segment can be located anywhere in the memory. Each of these segments can be used for the specific function. That is, the code segment is actually used to storing the instruction or program of the 8086. The stack segment is used to store the stack data, which will be very important in the case of a function call and also while calling the interrupt. The stack data is very important in the case of interrupt calling and function calling. In that case, the stack data can be used to store somewhere. How to store some stack data into the memory? For that, we are using the stack segment. Data and extra segments are used to storing the data or information. Okay. In assembly language programming, more than one data, code or stack segment can be defined, but at a time only one segment can be activated by giving the starting address to the corresponding segment register. Here is an example for physical address calculation. Here a base address is given 1234. It is actually 16-bit. Corresponding binary is given here 001, 0010, 0011, 0100. Then offset is 0022 and corresponding binary is given. Then in order to convert this physical address into 20-bit, we are shifting 4 positions to the left, so that otherwise we can call it as a appending 4 zeros to the right. Then we are adding to the offset address. Finally, we will get the 20-bit physical address, that is 12362. Okay, thank you.